So for question 23, as we can see here, we have x squared plus y squared equals to 2y. So we have to find dy dx. So this is our implicit, because our x equation and y function, they are missing together. Then we have to differentiate again to show that we have this d2y dx squared. So for the first part, when we have x squared plus y squared equals to 2y. So we're going to differentiate it separately one by one. So we're going to differentiate this x squared, differentiate this y squared, and then at the same time differentiate this 2y. So x squared we differentiate, we get 2x. Then y squared, we assume this y like x, so differentiate we get 2y. Because this is a y, so it will be implicitly dy dx. And then when we differentiate 2y, so we get 2. So because of y, implicit, it will become dy dx. So for this equation, we can simplify. You can see our coefficient here is 2, here also 2, here also 2, so we can divide by 2. So once we simplify this, it will become x plus y, and then here is dy dx equals to dy dx. So now we're going to find out what is our dy dx. So means that we're going to collect this dy dx. So our x will be equals to, we're going to move it together, minus y dy dx. So we collect them together. We factorize out our dy dx so that we will get 1 minus y. So finally, dy dx we can get here is x over 1 minus y. So we divide this 1 minus y to the left hand side. So this is how you get our dy dx, first derivative. Then we have to proceed to show that second derivative is the answer like this. So our answer is 1 over 1 minus y cubed. So from here, we will proceed to find our second derivative using this equation. So using this already simplified equation, of course we won't use this because it will be quotient, it will be complicated. We will use an equation easier than using a quotient. So for this like x, when we differentiate it, second derivative, we will get 1. So for this part, y and dy dx. So y and dy dx, we consider it as two functions, y times dy dx. So when we want to differentiate this, we will use product rule, which product rule is saling yang depan, differentiate yang belakang. So we set up the product rule plus saling yang belakang, differentiate yang depan. So this is our product rule setting. Saling yang depan, okay, this is going to differentiate later. Saling yang belakang, we're going to differentiate later. So when we want to differentiate yang belakang. So for dy dx, when we differentiate again, it will become d2y dx square. So differentiate yang depan, because differentiate y, we get 1. So because of y, it will become dy dx. Differentiate y, we get dy dx. So this is how we differentiate y. Then we continue. For the term at the right hand side, when you want to differentiate dy dx, it will become d2y dx square. So we're going to collect our d2y dx square together. So this d2y dx square, we'll move it to the right hand side. So it will give us a 1 plus dy dx square. So this d2y dx square, I move it to this part, I move it to the right hand side, minus y d2y dx square. So what can we do? Notice that our d2y dx square is in terms of y. So means that this dy dx we're going to substitute with this term. So it will become 1 plus x 1 minus y square. So for this part, we factorize our d2y dx square, it will be 1 minus x. So that's why, because I want to show it is 1 minus y. So that's why I will move this d2y dx square to the right hand side instead of moving this to the left hand side. Because if I move this to the left hand side, I will become y minus 1. So when I move this to the right hand side, it will become 1 minus y. So it is more easier for me to obtain this part, 1 minus y cubed. So I rewrite it, d2y dx squared 1 minus y. So for this part, so we're going to simplify this part. So when we expand, it will become 1 minus y squared. So we're going to get same to the denominator. This part also multiply with 1 minus y squared, then plus x squared. So originally, if you can see, x squared, when x expand, x squared. When 1 minus y, denominator expand, 1 minus y squared. Because here got 1, we have to operate this. Get same to the denominator, and so that this part will multiply with 1 minus y squared. So d2y dx squared, we continue. So when we move this factor to the right hand side, it will become 1 minus y cubed. So at the same time, what can we obtain here? So we have to prove it until we get 1. So for here, we can try to expand. When we expand this square, so it will be a squared, then 2ab, and then b squared. Okay, so a squared, 2ab become negative 2y, then b squared. So notice that x squared plus y squared, given that our question, our x squared plus y squared is equals to 2y. So means that this x squared plus y squared is equals to 2y. Therefore, we substitute that part. It will become positive 2y. So plus minus will become 0. So when we have plus minus finish, so that will be our expression. Showing off this answer is 1 over 1 minus y cubed. So we continue for part 2. Once we finish our dy dx, our second derivative, hence expressed in terms of y. For this means we're going to substitute our dy dx. Okay, we substitute our d2y dx squared, and then we have to simplify everything, and then let the answer in terms of y only. Okay, so no more expression in terms of x. So our questions here will be 2 over x times with dy dx squared, and then minus x squared times with d2y dx squared. So this is our questions. So this is cube. Okay, then we can start. Substitute our dy dx with x over 1 minus y cubed. Substitute d2y dx squared. Okay, so how we going to simplify? Of course, we are going to simplify our bracket here first. When we have cube, so we're going to expand it will be x cubed. So denominator, it will become 1 minus y cubed. So from here, you can notice that we get similar term. So from here, when we multiply it, it will become x squared over 1 minus y cubed. And then we can see our x here. For the first term here, we can see our x here. So our x can be simplified. So here will become square. So then we continue. Look at our denominator. We have same denominator. So when we have same denominator, we can get this both to the same denominator. So it will become 2x squared minus x squared. So we simplify it. So simplify it until we get in terms of y only. So once we simplify 2x squared minus x squared, we get x squared only. So how we change this x squared in terms of y? So we can use our questions, originally from our question. So from our question we have x squared plus y squared equals to 2y. So when I need x squared, so it will become 2y minus y squared. So I can substitute inside. Therefore, it will equals to 2y. So we continue here. 2y minus y squared over 1 minus y cubed. Then I write it in proper. We still can factorize y here. So 2 minus y over 1 minus y cubed. So this is how we express our questions in terms of y. So lastly, change in terms of y.